discuss Codechef status 134. Okay, so let's discuss the problem number second, long drive. Okay, chef and chefin are out on a long road trip. So basically the problem statements and states that the average speed of the car after 10 hours of driving is x kilometer per hour. Okay, it's x kilometer per hour. An average means an average speed. Chef wants to achieve an average speed of y kilometers per hour. Okay, target is y kilometer per hour. Okay, so given that he travel a maximum 100 kilometers in 1 hour, so he travels 100 kilometer in 1 hour. Okay, so we have to find the minimum number of additional integer hours required for him to reach the target average speed. So basically let's see some example. So our x is here 50 and y is 51. So basically the average speed means speed is equals to distance upon time. Okay, so distance is equals to speed into time. So we have been multiplied speed into time, so we have got our distance. Okay, so as we got our distance, we have to cover additional 61 kilometers in next hour, so that in next 1 hour. Okay, so that we will get our average speed as 51. Is that clear? So in this problem statement we will just use a simple formula. Okay, 10y minus x divided by 100 minus y, and this we will use as a lower function. Okay, this we will use as a ceil function. Is that clear? So that it will round off the value to maximum one. For example, let's suppose 10 by 49, 10 upon 49, what will be its value? It will be 0 point something. But if we use ceil, so its value will be 1, round off to 1. Okay, so this is the basic idea of using ceil function. So we have just break down this equation and created this equation. Okay, so let's go upon the code. Yes, so basically we have to import maths function here, and we took x and y as inputs. So what we have done, we have used ceil function. Okay, and use that formula 100 into 10 into y minus x upon 100 minus y. Okay, and just then print the answer. Okay, so now let's move on to the next problem statement. So our next problem is distinct substring. Okay, in this problem statement we have been given a binary string consisting of 0 and 1. Okay, so basically in this binary string we are having 0 and 1. We define an island as a substring consisting of all zeros bounded by ones. Okay, means an island is basically a substring of 0 and 1, means it is bounded by 1 only. Okay, so this is the main idea, means it must be bounded by 1 at either left or either right. Okay, so for example, we have been given a substring 1 triple 0 4 0. Okay, so basically here the uh, three zeros consist of one island. Okay, because it is bounded by ones. Okay, and the other four zeros also consist of a second island because it is bounded by a single one. And the main idea of this approach is the number of zeros goes on increasing, means island to island the number of zeros go on increasing. So basically we have been given positive integers n and k. There are exactly k islands in the string, and each island has a distinct length. Distinct length in the sense means it can have 1 0, 2 0, 3 0, 4 0, and so on. Okay, and so on. So basically, means the means the number of island goes on increasing and increasing in number, and the number of ones also goes on increasing. So basically, we have means it just count of zeros are 1 2 3 and 4. So basically, to find the sum of all these zeros, there is a formula n into n plus 1 by 2. Okay, by this formula we can find the number of zeros. Okay, so now we got the zeros, means first this is one island, this is second island, this is third island, and this is fourth island. Okay, 1 2 3 and 4. Okay, so basically how many zeros are there? 10. Total 10 zeros are there. Okay, so if we apply this formula, okay, if we apply this formula, means how many strings are there, how many islands are there? Wait a minute. This is 1, this is 2, this is 3, this is 4. So total 4. So if we apply this formula in 4, in n into n plus 1 by 2, we get 10. So our answer is basically 10 only. Okay, so this is our answer. So now you got the approach. Now how can we calculate the number of ones? Okay, means what approach we should use to calculate the number of ones. So just a simple thing, we will just in this formula n into n plus 1 by 2, we will just add the length, means the what we have been given the length of the binary string. Okay, the length of the binary string minus 1, means this gives us the last element, count of the last element of the binary string. Is that clear? So basically let's solve this problem with the help of an example. Okay, so we have been given 1 1. So basically our n is 1 and k is also 1. Okay, so how we can apply this formula? Basically k into k plus 1 by 2 plus k minus 1. Okay, so basically the count of zeros is basically 1, means k is what we have been given. K is the required number of islands. Required number of islands is zeros. Okay, so now let's use the formula. So we have been got 1 as our answer. So as 1 is equals to n, okay, our answer is equal to n, so we will print the yes. Or else if the length is smaller than, if our length is smaller than or equals to n, okay, we will print yes, else no. Let's talk about the next example. 3 1, our n is 3 and k is 1, means in 3, means the length of the binary string must be 3. What must be the length? Length must be 3, but the number of island must be 1. Okay, so basically what can be the number of islands? Okay, it can be 0 0 1, it can be 0 0 0, it can be 1 0 1, okay, or 1 1 0. So basically these are correct because it is creating one substring, it is also creating one substring, it is bounded by one, it is one substring bounded by ones, it is also one substring bounded by ones. Okay, but the string 111 111 and 010 are not valid. Okay, why? Because in this there is no island, zero island is not there. Okay, and in this there is a separation between two zeros. If let's means keep in mind, if there is a single one in between two zeros, means there are two separate islands, means in this we have been given one and two islands. Okay, so if we do like this 100 for this or 001, so this can be valid, but this is not valid. Okay, so basically we will print yes over there. Now next one is basically what, 6 and 3, or n is 6 and k is 3. Basically now we will find the length of zeros. Okay, length of zeros means 3 into 3 plus 1 by 2 plus 3 minus 1. Okay, so basically this is 12 by 2 plus 2, which gives us what, 8. Okay, so what I have talked about, so 8 is our length. Okay, so what I have basically talked about, so the length must be less than or equals to n. Okay, but here our length is 8 and n is basically 6, so it is greater than, so just we will print no over here. Okay, and our last is 7 comma 2, this is our n and this is our k. Just what we will do here, apply the formula, 2 into 3 by 2 plus 2 minus 1, which is equals to 3 plus 1, which gives us 4. So basically 4 is less than what, less than n. Okay, which is 7, so we will just print s over here. Okay, so I think you got the approach. Let's see the code. Yes, so basically this we took input. Okay, then sum of all zeros. Okay, like 0 0 0 0 0 0 and 0 0 and so on. Okay, and basically this k minus 1 is sum of all ones in substring. Okay, and basically L is length of substring. L is length of substring. Okay, if it is less than or equal to n, then string is valid. Okay, so now I will just write here the explanation of one example. Like we have been given 7 comma 2. No, let's suppose take the example of here only. Yes, 7 comma 2. Yes, basically 7 comma 2. 7 is our n and k is 2 is our k. Okay, yes. So length of means sum of zeros, okay, equals to 2 into 2 plus 1, 2 into 2 plus 1 by 2 plus, okay, this is our sum of zeros. Okay, so basically it is what sum of zeros, it is basically 3. Okay, 3 is our sum. Then sum of ones, it is basically what k minus 1. Okay, so k minus 1 is basically 2 minus 1, which is equals to 1. Okay, and last the length of substring, length of substring is what, it's basically 3 plus 1, which is equals to 4, as 4 is less than n, which is as 4 is, wait, as l equals to 4. Okay, and which is less than what, n what it is, 7. So just print yes. Okay, so basically this is our main approach. Yes, it's giving correct output. Yeah, we got our correct answer. Okay, wait a minute. So now let's move on to the next example. So basically you can see here we have got only one over here. Okay, here. So this is basically the two islands, 1 0 here and second 4 3 zeros here. Okay, so this is the main approach. Let's move on to our next question. Next problem is prefix suffix inequality. So basically we have been given an odd integer n. Okay, just we have been given odd integers as input, and we have to generate an array A of length n. Okay, we have to generate an array of length n. So basically in this we have to do bitwise and bitwise XOR. Okay, bitwise AND of each prefix array is greater than or equals to bitwise XOR of corresponding prefix array. Also bitwise AND of each suffix array is less than or equals to bitwise XOR of corresponding suffix array. It can be proved that at least one solution exists. If multiple solutions exist, you can print any one. Okay, you remember this line. If multiple solution exist, you can print any of the line. Okay, so for basically we have been given an array. So basically this is the prefix. Okay, and this is the suffix. This is basically the prefix and this is suffix. Okay, so now for each prefix array, say the bitwise AND is greater than the bitwise OR. Okay, for each prefix array. Okay, for each prefix array, prefix AND is greater than or equals to prefix OR. Prefix AND is greater than or equals to prefix OR. Okay, for also for each suffix array, for each suffix array, for each suffix array, what suffix AND is less than or equals to suffix OR. We will discuss what is AND and OR. Suffix AND is less than or equals to suffix OR. So basically this is the logic we have to apply. Okay, these two statements we have to confirm and then print an array, okay, of size n. So basically what we have to do is just let's try to solve an example. Let's suppose we have been given n equals to 3. Okay, we have been given n equals to 3. So we have got an array 563. 563. Okay, so basically the bitwise AND of 5 and 6. Basically first we will start with suffix, means prefix. First this, then this, and then at last this. Okay, same as suffix, this and for suffix. So basically this is the main logic we have to apply for 5. First of all, for 5 what we have to do, bitwise and bitwise OR of 5 is equals to 5 only. Okay, both for and both for OR it is 5 only, so both are equal. Okay, now we will go for 5 comma 6, 5 comma 6. So 5 and 6 equals to 4. Okay, also 5 XOR 6 which is equals to 3. So basically what's the statement says, for prefix array, okay, for the prefix array the prefix AND must be greater than or equals to prefix OR. Okay, so we have got that prefix AND is greater than equals to prefix OR. Okay, prefix AND is greater than prefix OR. Now we will go to 5 6 3. Same logic, 5 and 6 and 3 which is equals to what, 0. Also 5 XOR 6 XOR 6 3 equals to what, equals to 0. So both are equal, so the given statement is valid. This is for prefix array. Now for suffix array. Suffix array means this green one, as you are able to see, means we will start in reverse order. First 3 will be only means and XOR of 3 will be same only, so this is done. Then what, 6 comma 3, Okay, what is the, we will take the AND of 6 and 3. 6 and 3, which is equals to what? 2. Also 6 or 3, which is equals to 5. Okay, so basically we are able to see that the suffix AND is less than the suffix OR. Okay, means from this formula which is I have written here. Yes, so suffix AND must be less than or equals to suffix OR. Okay, so now basically we have got our suffix AND is less than suffix OR. Okay, now we will move forward to whole 563. Okay, the AND of 5, 6 and 3, which is equals to 0, and 5 or 6 or 3, which is also equals to 0. So 0 equals to 0, so the whole statement is valid. Okay, so we have got our, means our 5 comma 6 comma 3 is the correct array, which proves the these two statements. Okay, these two statement must be proved. Okay, means the we have to find the array which can prove these two statements. Is that clear? So now we will go for our next array, means for n equals to 5. Yes, so now basically, yes, so now what we will do? Okay, so now for n equals to 5. Okay, for n equals to 5 we have got an array 75773. Is that clear? Let's suppose we can take n equals to 4. So basically our array will be 7573. Okay, as you can see that for prefix it will go here, and then for suffix it will start from 3, then 37, then 35, and then whole array. Okay, so as you can see that the prefix sum of the individual elements satisfies the condition. Okay, first 7, then as 7 is the individual element, so it will be satisfying, then 7 comma 5. Okay, for 7 comma 5, 7 and 3 is what? It's greater than or equals to 7 or 3. Okay, then what? 757, what 7 and 5 and 3 is greater than equals to 7 or 5 or 3. Is that clear? So it is satisfying the condition. Then what 5 7 3 means 7 and 5 and 7 and 3 is greater than equals to 7 or 5 or 7 or 3. Okay, so this is also satisfying the condition. Also for same for suffix array. Okay, same for suffix array. So now we can see that for n equals to 4 our array is 7 5 7 3. Okay, then for n equals to 5 also our array is 7 5 7 7 3. So we can see that our 7 5 3 are constant, just we are increasing this 7. Okay, our 7 5 3 are just constant. Okay, we are just increasing this one. Okay, or basically for same n equals to 6 it will be 7 5 7 7 7 3. Okay, so basically this is the basic logic. We have to just increment these sevens. For this what we will do, we will just declare a list. Okay, we will declare a list and initialize the first element and last element as 3. Okay, and then we will initialize the list with all sevens. Okay, so this is the basic logic. Now let's try to understand the code with the help of means let's try to run the code. Okay, first of all, first I will take test cases as input. First I have taken the input, the test cases, then I will take n as input, then I will initialize. Okay, what I will initialize, if n is equal to 1, first of all I will create a result list. Okay, if n is equal to 1, what we will do, result equals to what, 1. Okay, result equals to just 1. Then else if n equal to 3, what will be a result will be equals to 5 6 3. Just I am just copying down from here. Okay, then elif n equal to 5. Okay, if n is equal to 5, what will be the result will be equals to what, 7 5 7 7 3. Is that clear? Okay, so now we will apply the else statement. Else we will initialize the list result with 7. Okay, 7 multiplied by n. So basically what does it mean, basically? Okay, if n is equal to 6. Okay, so the result will be equals to 7 multiplied by 6. So basically what will be there, our result, what will be there, our just our result will be equals to, our result will be equals to what, it will be equals to 7 times n, 1 2 3 4 5 6. Yes, so we have got our list. Okay, so if n equals to 6, so this will be the result. Okay, now we will initialize what, the first element, the first index will be equals to, the first index of our result will be equals to what, 5, means our result will be equals to what, result will be equals to 7 5 7 7 7 7. Okay, so we have initialized first element with 5. Now we will initialize last element we denote as -1, last element as what, 3. So our result will be just equals to what, 7 5 7 7 7 3. Okay, so this is the basic. Yes, so now what we will do, we will just print the values of result. Okay, we will just print the values of our result. So now let's try to submit the code. So basically we have used here star means pointer, it just prints the values inside the array, means it's giving correct answer. Let's suppose if I just print the result over here. Okay, if I just print the result over here, I just show you the use of pointers. Yes, it's just printing the, means it's printing the output with brackets. Okay, if you want to remove the bracket, we use the star. Okay, just we use the star. So now you can see that the brackets are removed. Yes, so now I think you understand the code. So let's move on to the next question.